So hello, everybody. Welcome to the fifth Java workshop, Temporal Java SDK Workshop. I guess my name is Tihomir. I think you guys know who I am, and we have Dmitry and Tom Wheeler from Temporal here. Dmitry is the SDK lead. He writes all the code and fixes all the bugs that all of us find. Typically what happens is, if Dmitry, I would like for you, if you have a minute, to give just like an update of what's going on with the SDK like we did last time, and go ahead and then we'll get started. We have a bunch of stuff to talk about like usual, and it's usually just like what this meeting is really about is we're not doing some sort of intros. If you're interested in the last four workshop videos, we have them all online on the Temporal channel under Java, I think, SDK, and you can go ahead and watch those. But we kind of go into deeper issues and really focusing on user questions. So we have our community forum. I think you guys have been, probably seen it, and also the Slack. We provide open source, free support to you all. And yeah, so everything that we do here is based on somebody has asked this question, somebody had a real problem, and we came to some sort of solution. And in this video, we kind of go over it, run a lot of code, and go through a lot of stuff. So that said, Dmitry, you want to give any updates for the Java SDK? Go ahead.
There is actually not that many this time. So the Spring Boot is in active development. We probably will, in July, most realistically, publish some bare bones Spring Boot that will allow to start an application with workers, with registered workflows, activities, all wiring together and working. And starting from there, we will collect feedback and we will think how to better improve the configuration options, because in Spring Boot, there is usually two ways, through annotations and through the config file. So basically, the main goal of the bare bones Spring Boot will be collecting feedback and rethinking if it's the right direction. And that's pretty much it in terms of like new features. Everything else, I'm mostly right now, like the last month, I'm focusing on solidifying local activities, functionality, and experience for Java SDK, because there is more users, more companies who are actively using local activities in Java SDK at least, and it just shows quite a bit of bugs in this area. That's it.
Cool. Thank you so much. All right, I'll go ahead and share my screen just to get us started. Hopefully it works. So for these workshops, I've also put it in chat as usual. We do have a GitHub repository. This is kind of still my private. Hopefully we'll move it to the Temporal repo at some point, but it's still here now. And it's temporal-java-workshop. And here you will find, README has all the other workshops so far and the links to the videos, so you don't have to search for them on YouTube. In addition, all the code that we have shown so far and that we're going to show in this workshop as well is all here. And this is kind of like an addition to the Java samples that we have. And I think, it's kind of helpful sometimes for everybody to kind of, go through it and look at the samples, and also have, some code here that you can cut and paste. But anyways, for our workshop here, if you were here last time, we started doing a lot of how-tos and patterns. The first three kind of workshops were really focused on the, kind of showing what is the Temporal Java SDK, what does it do, and kind of looking at features, how to define workflows, activities, all this stuff, and how to test workflows. And slowly, kind of, we've moved on to some cool stuff. And last time we described a bunch of different patterns, for example, polling, recovery fallback, pipeline execution, busy loops, and stuff like that. So if you want to look at that, make sure that you watch the last video. In this workshop, we're going to kind of continue that. And we're going to kind of look at a number of kind of questions, not exactly related to learning the concepts of Temporal, but to actual implementation of some sort of business requirement that one of our users, mostly we take them from our community forum. One of them I think here is actually from today, from Slack, a Slack question, and we want to provide an answer for that. So the first thing that we're going to look at is something called a bulk request. And this is, if you look at the code, it's in C5S1 package. And I'll make this a little bigger. But just to kind of explain the situation is, this particular user has a third-party service which accepts bulk operations. So typically when we talk about interacting with a service, we think about a REST endpoint that we send some data to, and it's usually one workflow, one activity to one service type of location. In some cases, we have services that allow us to let's say, for example, process multiple users or transactions at a time. And when you have multiple workflows running and they're all running on different, have been started on different times, or have different business logic, but they all have to, for example, access the service. And this person is basically asking is, I have 3 workflows they're currently running. All of them have to access this third-party service, which provides bulk request ability. How can I actually, do this? How can I sync up my workflow invocations to kind of send all together a bulk request to this third-party service? And to kind of show this, we have 3 workflows here. This is workflow A, workflow B, and workflow C. And all of them have to send a request to our, let's say, service, which is invoked by our call bulk service activity, which takes in a list of strings. And then for each one, let's say we just right now system out, but you can, we can send the REST and request to an endpoint of the service with all of the, let's say, for example, customer IDs rather than one at a time sent from each workflow. And the solution for this is we're going to have a long-running workflow called bulk request to workflow. So instead of these workflows trying to communicate with each other somehow and maybe figure out how they can all, because in this case it's 3, in your case it could be 100. One way with Temporal to solve this is to have one workflow which actually accumulates these requests. In this case, our workflow has a signal method called request service, where each of the individual workflows that want to kind of together send a bulk request together is going to signal this service. This service is going to store the signals, in this case, in a list. And, simple sample, it's going to wait, we're going to wait for 3 of these particular signals to come in. And when they come in, for the sample, we have 3. In your sample, this could be a lot more, or it can be based on a timer, for example. Like, let's say I'm going to wait 5 minutes, and then whatever I get, request I get, I can send to my endpoint that allows this bulk request processing. I'm going to do it after, let's say, every 5 minutes. And what is it going to do is it's going to call our bulk service activity, sending all of the requests, in our case 3. And then after it's done that, each one of these workflows, or workflows A, B, and C, need to be notified when this bulk request is completed. And to do that, this particular workflow can use external workflow stub. And for each of the services that we got our signal for, which comes in with a requester ID, we're going to signal the services back saying, hey, the bulk request is completed. And each one of the particular workflows here is going to then wait for the response and then continue execution of whatever he needs to do. So just to kind of run this, and hopefully we'll see what happens. All right, so what we have here is, and let's take a look at the web UI. And I'm going to use both interchangeably, web UI version 1 and 2. But since a lot of our users I've seen are still on V1, I think this is fair, but we're definitely also going to look at V2. So anyway, so our workflows A, B, and C, if you see, for example, the workflow history for how do you say, for workflow C is going to send actually a signal to our bulk requester workflow. But one thing I wanted to show is like this is actually done via an activity. And the reason for that is that our three workflows that are actually sending the signal may not know if our bulk requester or this workflow that is long running and receives all the requests is actually running at a time it wants to send the signal. One way of doing this with Java SDK to actually signal another workflow is to use external workflow stub. But external workflow stub requires you to have a workflow ID and a running process. So what these three workflows actually do is if we look at the activity implementation, they're going to send the signal to a bulk workflow via signal with start. And this is kind of showing that inside of your activities, you can actually use the client APIs too. So in here, just like we would do it, let's say a quote unquote starter or your client code, the request sends a gRPC request to start workflow execution. Inside of your activities, you can do the same. So in this case, we just create a workflow stub to our bulk request to workflow, and we call signal is start, sending this information actually from the activity. And this will allow us to have the signal with start capability, which means even if you see in the starter, we actually never start the bulk request to workflow. We simply only async start workflow A, B, and C. But as soon as workflow A, for example, first sends out the request to the bulk workflow, which is going to use signal with start will check for you, hey, is this workflow running? If it's not running, like for example, in this case, it's going to create execution and then send the signal to it. So just kind of to show you that is one of the ways that we can kind of solve this particular problem. If you have any questions, feel free, to ask at any time and interrupt or whatever. But we'll keep going. We have a lot more to look at. And let's take a look at back our second thing. One thing I wanted to show, and it's actually something that our users are asking, a lot of times we have to deal with cancellation. And there is always like a question, hey, I have, for example, a workflow that runs a child workflow. The child workflow executes some activities, but I want to cancel the child workflow, and which should trigger cancellation of the activity it's running. But my workflow that's initiating the cancel needs to wait for all these cancellations to happen, before it can actually, for example, complete execution or move on to something else. So as an example for that, this is in our C5S2 package. We actually have a workflow implementation. I'll make this bigger, which starts a child workflow. And one thing that's important as far as child workflow options is you have a cancellation type property that you can set. And there is a number of different cancellation types in Temporal. You have try cancel, or you just try it. You wait until the cancellation is only requested to the child workflow. But in this case, since our user, in this case that asked this question, wants to wait for the cancellation of the child workflow to complete, we use the child workflow cancellation type wait cancellation complete. Another thing is, because we're not canceling the workflow itself from the client, but you can also cancel a child workflow from within the workflow code. For this, what we do have to have is a cancellation scope. So you've seen probably in the Java samples, cancellation scope being used for like activities, which makes also, it's fine. But in this case, you can also use cancellation scope for one, in this case, or more async invoked child workflows as well. So what we're going to do is, instead of just using async function, which is going to create a new workflow thread and start the child workflow execution async, we wrap this in a cancellation scope. And we say cancellation scope run. This is required for this cancellation scope code to start running. And at some point later on, we actually want to wait for this async child workflow to complete. So this is on 28 is a blocking call, blocking on this particular promise, child promise, which is going to wait for the completion of the child workflow. Now, we have a signal method here, which is called do cancel. And what that's going to do inside the signal method, we're going to call child scope.cancel. So while, what's basically the sample shows is our workflow is going to start, is going to create a child workflow execution, but then from the client, we're going to send a cancel signal, which it is going to cancel the scope of this, the cancellation scope and the child workflow that's running inside of this cancellation scope. Now, again, looking at the cancellation type, we want to wait. So our workflow needs to wait until the child workflow has confirmed the cancellation. So let's take a look at the child workflow itself. Now, the child workflow executes, for example, one activity, also async. So it's the same thing. Now, the cool thing, with this is you don't have to put the async invocation of this activity in a cancellation scope because the cancellation of the child workflow is going to trigger the cancellation of the context also of the activity that's currently running async. But the same thing in here, we call activity promise.get. So we basically start an activity async, and we are going to wait for it to complete. Now, what's going to happen here is from our starter, we start our workflow execution, and then we send it the cancel signal. The cancel signal is going to cancel our cancellation scope here. And at that point, two things are going to happen. Our child workflow, which is executing this activity, is first going to, the activity is running. And one important thing about this activity, it has to heartbeat. So for example, what our activity does, and in order for an activity to receive cancellation signals, you have to heartbeat through its context. Or if you're doing, for example, async activity completion, we are a completion client, you can heartbeat from that completion client as well, I believe. So in order for this activity to learn about the cancellation of the child workflow that has invoked it, we have to heartbeat. And here we heartbeat every 1 second. And once the child workflow has been canceled or by the parent workflow, on the next heartbeat, this particular activity is going to receive an activity canceled exception. What we want to do, because even in child workflow options, in activity options, we also have a cancellation type. So since we want, from the beginning, we said we want to wait for the activity to complete cancellation, the child workflow to complete cancellation, and then the parent workflow to be able to then do something after all these cancellations are completed. We also have a cancellation type on the activity options. And again, you have a number of different ones that you can use: try, cancel, abandon, or in this case, we want to wait for the cancellation to complete. The way the activity, once it heartbeats, so after the child is, the next heartbeat after the child was canceled or receives the cancellation request, is going to, we have to return throw the error. So this basically says, hey, I've completed cancellation. At that point, since our child workflow is going to receive an activity failure. Now, this is kind of with Java SDK, we talked about failure handling before. Any failure that comes for an activity execution is going to be converted to activity failure. And in our case, what we're going to get, the actual cause of this activity failure is going to be canceled failure. So in our child workflow, we can catch activity failure, we can convert it to cancel failure. And again, since we're waiting on the parent, the child is going to denote completion of the cancellation by just rethrowing it back to the parent. So in this case, our parent catches actually child workflow failure, because again, in the Java SDK, all the, whenever a child exceptions, you can catch child workflow failure, and it can basically do whatever it wants here, like do some system outs. So that's kind of the idea. So it's a cascade completion, cancellation, and waiting for whatever is currently running as far as activities and child workflows and their cancellations to propagate back to the parent before we actually want to handle the error and then perform some business logic too. That might be necessary in this case due to this cancellation. So we can run this as well. That's fine. I think this code should run fine. And okay, oh, that's fine. Our worker is spitting out some errors, but in anyway, so our child in here, I'll make this bigger, was invoked. We received an activity failure, meaning the activity on the next heartbeat after we triggered cancellation has failed with, again, the activity canceled exception. Child workflow was able to handle this, and it did some cleanup before it itself threw the child workflow exception back to the parent. The parent, in this case, received child workflow failure. It was type canceled failure, so we know exactly in our parent workflow that we're dealing with cancellations and can handle it accordingly. We did some cleanup, and we said, fine, we're all canceled, we're good to go. Yeah, so in this sample, we're just doing one activity, but or one child workflow. You can do multiples as well, and as many as you need, and cancel a number of them if you want as well. Any questions so far? No. All right, we'll move on. Save everybody time. Now, this one, I think it's kind of interesting. And the next thing we want to talk about is handle multiple distinct signals in order. And one thing that kind of users always ask is, how do I, because our clients can send a bunch of signals to our workflow. And those are going to, of course, the signal handle methods are going to be handled in their own workflow thread. But how, if we really want our workflow to process one at a time, and we do have in our, sorry, I'm just going to do it this way this time. We do have in our Java samples, in hello, we have a hello signal test, sample. And in this case, this is kind of what we do. We have a single wait for name signal method, which we keep writing every time we receive a signal. We write it to a list, here a list of greetings. And in our workflow, what we want to do is we process it one at a time until we get some sort of exit signal. So if we have one single type, which, if you remember, a signal type in the Temporal SDK is the name of the signal handler by default, this is fairly easy to do. But as soon as we have, like, for example, multiple signal methods, and what we're going to see actually here, I think in the next one. Okay, so here we have our workflow, which is very similar, but we have three signal methods, and each one takes a different object as input. So this solution of like just storing all these objects in list and processing it one at a time may not really be optimal, right? And how do we handle it here, right? And one of the things that we can do is, and I'll show you this, what I mean. Let's just kind of go from the starter and we'll go from there. So our starter, basically, we have this workflow. We're going to send our signals in some sort of order so it's readable for us to see what's going on. And it's going to send signals A1, B1, C1, and then A2, B2, and C2. Our signal methods are going to actually run activities. And this is one thing that a lot of people also ask, hey, can I actually run activity in or write workflow code inside of a signal handler? And the answer is yes, because they are running in a workflow thread. You can do this in a query method, right? A query handler. By signal handler, it's fine. So every time we receive a signal, we actually execute an activity. And this activity is because it could, in this sample, is one, but in other cases, in your case, could be many different ones. We kind of randomize it. So our activities are going to sleep between 1 and 4 seconds, just to kind of simulate that different activities can execute for different amount of time. But what I wanted to show you is that without any code or any implementation, simply just executing our activity, the order of our signals is not going to be preserved. And the reason for that is that each one activity is going to run for a different amount of time. So even though we receive signal A1 first, you see that, for example, and then the activity for A1 actually took a lot longer because of the random number we are generating for sleep than activity 2. So we see the order of the signals that we have sent and the order of activities that was executed by our signal handlers does not match, right? And that is a problem that we're trying to solve right now. And one way of solving it, that we also have the solution on the forum, is to have a little lock. So because this is feature as far as sync signal handling is not implemented yet on the server side, but it's something that we're planning to add in the future. Right now, what we can do is implement it kind of like our poor man's version of that. And one way of doing it is we can have a Boolean in our workflow code called signal lock. And basically in our signal methods, what we can do is we can wait until the signal becomes true. We set the signal lock to false. We execute our activity. And finally, we unblock our lock or set it to true. And we have to basically do this, and I'll show you how to actually not have to do this here in a minute, in every single one of our signal handlers. So what this means is that as soon as a signal comes in, its signal handler gets invoked. The signal handler method is going to lock other ones because they're still going to wait for the signal handlers to release the lock. And it's going to, everybody else is going to wait until the signal that's currently handling the signal unlocks or sets the signal lock to true. So if we actually run this now, hopefully, let's see, yep. We see that, well, let's see. Yeah, so even though our signals are received in our activities that the signal handlers are running a completely different order, we see that with a very simple implementation, couple of lines of code, we can actually process now our signals in order. Okay, so fine, this is actually cool. But the problem is that if we look at this code, it's really ugly. I mean, we have to kind of apply this to every single one of our signal methods, and we don't really want to do it. Our code actually should mimic business logic. So I'm going to get rid of this completely. Yeah, I guess I comment some of the stuff I should. So our code really should look like this. When we receive a signal, we invoke the activity. But we want to preserve the order within our workflow code without actually having this bunch of code that has nothing to do with your business logic polluting your workflow code. And one of the things we can do this with is using interceptors. So Java SDK has interceptors, right? And you can intercept like a lot of different stuff. And if you have questions, I know Dmitry can talk about that for days since he kind of wrote all this. But what I'm trying to show you is that instead of having to write this into our workflow code, we have a little order intercept. We call him order interceptor. An interceptor or a worker, which is a worker interceptor. You have different types of interceptors too, right? You have client interceptors, worker interceptors, and Dmitry, tell me if there is any other type of interceptors. But basically, we're going to create a worker interceptor, and we have two methods. One is going to be our workflow inbound calls interceptor and our activity inbound calls interceptor. Now, since we're not running in any activities, our activity inbound calls interceptor doesn't override any methods. But you see that if you want to override, there is a bunch of them in here, like execution. You can basically intercept execution of an activity. The one that we're kind of going to implement here is an workflow inbound calls interceptor. And in this interceptor, we can override the handle signal method, which means is that we can intercept the signal handler method via this interceptor in this case. And instead of writing this logic of workflow way signal lock and locking it up, what we're going to do, we're going to implement this logic with the interceptor. And when we provide this interceptor to our worker factory via options, which we'll see, this worker is going to apply this particular interceptor and call this method basically every time we need to handle a signal. So what we're doing here is it's very similar. We still have a signal lock. Inside of our signal handler interceptor method, because this is going to be executed in the same workflow thread as the signal handler itself, we can totally use our workflow API. So here we can even say workflow await. And then instead of actually calling the activity like we did in the signal handler, we're actually just going to invoke via super the handle signal, the actual activity, the signal handler here, which is just going to execute the activity. So you see, using interceptors, you can write these things and not pollute your, workflow code with stuff like that. We can write it in your little interceptor. Now, one thing to look at is how do we actually define this interceptor? And for this to actually, we have to configure it. So for this, we do it via worker factory options. So in our little method that creates our worker, we define worker factory options. We set a worker interceptor and give a new instance of our orders interceptor that we have created. And what we do is when we create our worker factory, we use this particular method called, we pass in the client like usual, but we also pass it our worker factory options, which are going to set our worker interceptor. And now if we run this again, so our workflow code does no longer have the locking that we needed before. We now offloaded that to an interceptor. And we see even now that the same is applied. So our interceptor is basically doing the same thing that we had previously in the code that we had in every one of our methods. And we're going to get our signal processed in the same order as what we have sent to the workflow here from the client. All right, does that help, or anybody have any questions or anything about this? No? All right, you guys. All right, so let's keep going. We can keep going with this and see what else we can do. So let's go back to our workshop. All right, so this one is kind of fun for me. What I like to do, and kind of what we've started also in the last workshop, is I like to break stuff. And, running into errors with temporal is probably the best way to actually learn it. Now, one thing that I wanted to kind of mention is a lot of times when we talk about temporal, we talk about this workflow determinism, right? And there is a bunch of videos and stuff. I'm not going to bore about this. But one thing I do want to show you that when you start reading the documentation, we do present these things called workflow implementation constraints. So basically, we're telling people all these different rules that you have to apply, or the best practices when starting writing your workflow code. And instead of, for example, using thread asleep, use workflow asleep, all this stuff. And this actually is very important to understand. And we also have one forum post on our community forum that Spencer wrote, which is amazing. If you go to community.temporal.io and you go to you go to the developer corner category, you'll find it right here. And make sure you read that. It's really good and it makes a lot of sense. The thing is that, okay, so this is kind of scary. When I write my code, I have all these rules and all that stuff. But in this workflow, what I'm going to show you is that it gets a little confusing, because this particular workflow code does exactly what we tell you not to do. Usually we tell people is that you can use, number one, random numbers inside workflow code. You should actually use workflow.new random UID or new random, which is replay safe, right? This code doesn't do that, right? It basically, what it does, it generates a random number between 1 and 10 and loops through that random generated number and calls an activity. That's what this code does. So really, if from the user perspective, if you actually read the documentation and saw all these videos and you wrote this code, you would think this should not work with temporal, right? But however, let's go actually try to run it. So I'm going to start a worker, and I've separated the starter and the worker this time to kind of simulate kind of the point of, I guess, this exercise. And I'm going to run this particular workflow that breaks all the determinism things. And what we have seen here, let's go look back at here, our workflow actually completed. And not only completed, it actually called, let's say, in this case, 1. I guess our random number for this case that was generated was 1. And it completed fine. It didn't break determinism of the workflow code. So from the user perspective, it's like, you're like, what the heck, right? What is, oh, sorry, I'm completely somewhere else. No, wait a second. Oh yeah, yeah. So why did this code work? Anybody has an idea or not? Dmitry doesn't count. So anyways, the reason why this workflow, well, let's kind of try to actually start from the beginning. A workflow execution is not bound to a specific worker, right? So with temporal, one of the things that you get, regardless of the SDK, is the execution is actually created on the server. The workers, it is not tied to a worker. So your worker can, your execution can start on one worker and continue on the next, right? That's first thing. So one of the ways we can think about is how can we actually get our execution to start on one worker and then continue to another? And another thing that we have to talk about is workers themselves. Workers have a cache. They cache workflows, right? So when a lot of times you hear, like, even like, I guess in videos and things like that, about this thing called workflow replay, and it has to deal with determinism. And it makes people think that every single time we block our workflow thread, like a workflow.sleep, or we call invoking an activity or things like that, we're actually replaying the code from the beginning. But the workers in Java and also other SDKs have a caching mechanism, meaning they're going to cache workflow executions, right? And they're going to cache it up to some number of executions. And in the Java SDK, this number is 600. And you can actually set it with worker factory options. You can default is 600, and you can set it via this particular parameter here. Now, what that means is that, and let's actually kind of look at, well, actually, how can I just draw something? All right, auto draw. So if we look at a temporal server here, yeah, you get it, my awesome driving. And we have our worker. Usually you'll think this worker, well, listens to a task queue, right? This is the task queue that you define when you create the worker, and that you also have to define when you actually request execution of this workflow. You have to define an endpoint. Workers, and this goes a lot deeper than I'm going to describe, actually also have something called a sticky task queue. And the first time, let's say the server puts our workflow task in the task queue, a worker picks it up. The next task that we're going to say the server puts on it can be on the sticky task queue. And worker maintain a workflow cache. So using the sticky task queue allows temporal workers not to have to get the whole history and replay from the beginning. And we can actually see this in our workflow history. We started here, and I'll make this a little bigger if I can. We invoked our activity, and when we get to the timer, which is our workflow to sleep, here you will see on the workflow task scheduled, the task queue being sticky. And here, I think you will see a task queue when we started workflow execution, the task queue kind for the workflow task scheduled event is going to be normal. And what does this mean? When our workflow execution started, our server has put the task queue on the main task queue partition, basically. So this is task queue normal. A worker picked it up. And at that point, a new task or workflow task that come for this particular execution can be placed on the sticky queue, meaning that the worker has this cache in memory, is going to pick up the task, and it's not going to replay our workflow from the beginning, and it's just going to apply the new instructions that it got from the server. This is why, in this case, this doesn't break, because as our workflow never replayed from the beginning. Our workflow task ran basically code from top to bottom, and every time we executed an activity, the next workflow task was placed on the sticky queue and was using the worker cache, so it didn't replay from top and completed fine. But how can we actually see why this code is bad? The way we can do this is, let's actually set this to, let's say, 20 seconds, this sleep, because I'm slow. Let's see if I can stop the worker. Is we can simulate this code being started on one worker and then be continued on another. So what I'm going to do is I'm going to start the worker again. And then I'm going to start the starter, which is going to start our workflow execution. And if we look at our workflow execution, it should be executed all our activities and be on the 20-second sleep. Now, at this point, I'm going to kill our worker. All right. So when we kill our worker, this simulates your worker being down. And when a worker comes back up, its cache is cleared. The cache is in memory. And when our worker comes back up, it's going to get the workflow task again, meaning it's going to try to run this workflow.sleep again. But because it's a new instance of our worker, and let's start it again, it's going to not have the cache. And in our case, wait, I guess I didn't do it for 20. Yeah, okay, but why did it? Okay, so we did get a non-deterministic exception, but I didn't wait in time. Sorry, the demo sucks. So let's start a worker again. I talked for over 20 seconds. So that's why our workflow kind of completed. So let's make sure that we get this time. It's running. It's on timer. Now, okay, and I'm going to stop our worker. I'm going to bring it back up, which will not have the cache, and it's going to have to replay the workflow from the beginning. And what we see here now is we ran into a non-deterministic exception, hopefully in the end. Why? So let me just refresh. Okay. Well, we got a workflow task timeout. Wait, I'm going to look through this for real quick. Okay, let's try it one more time. Sorry. Start the worker, because this is important. I don't know what I did. All right. Let's get the starter running. Make sure we have an execution. And stop the worker. Start it again. And hopefully our workflow will run into not our exception that I'm looking for. Come on, workflow. Okay, we're still on our 20-second timer. After the timer has triggered, we should get a workflow task. All right, time that. Okay, so here we go, finally. All right, sorry about that. Sometimes with the samples, but anyway, so our workflow right now is stuck And what we have here is a non-deterministic exception. Because we stopped the worker and then started it again, we basically didn't trigger replay of our non-deterministic workflow. Because we are not using replay safe temporal APIs, we got a different random number, and we started executing these activities. But during replay, we're going to compare our already completed workflow history with the code, and the activity invocations in our history are not going to match up with our code anymore. So what happens is we're going to run in this non-deterministic exception, right? The thing is with temporal is this workflow is still running. So we still didn't fail the workflow execution itself. We're actually failing this last workflow task, and the workflow is going to keep failing this workflow task, waiting for you to fix your code, your workflow code, and redeploy your workers so you can actually continue the execution of this particular workflow task, hopefully complete it, and then move on to whatever else the workflow code that we have needs to be doing. One thing that our users ask a lot is, and we actually had a user ask this recently on the forum, they're saying, look, I'm running into this non-deterministic workflow exceptions during my testing a ton. I don't want to really deal with versioning, for example, to fix these things. How can I just fail my workflow when I run into a non-deterministic exception? And the answer to this is we can't catch non-deterministic exception in our workflow code itself. But one thing that we can do is, one second, where is, okay, one second, starter, I'm all over the place. Okay, here we go. I had it here. So one thing that we can do is, if you want your workflow to fail a non-deterministic exception, you can actually do it via workflow implementation options. So in this case, we're going to, in our starter, build our workflow implementation options, and we're going to set failure workflow exception types. And we're going to set it to non-deterministic exception.class. And when we register our workflow implementation class with a worker, we're going to pass this option, these options. So in this case, what we're going to do is basically say, if I get this non-deterministic exception in my code, I want my workflow to fail. So let's kind of take a look if, how do you say we can actually do this? So let's go ahead and run our worker again. Let's go ahead and do our starter. See if it's running on a 20, it's probably on the 20-second timeout now, like the sleep. Yep, I'm gonna stop our worker, and hopefully we can break determinism again. Hopefully random number generator will be nice to us. All right. And in this case, once we get out of our 20-second timer, we see we did get in our history, sorry, the non-deterministic exception again, like we did before. However, because of our options that we set, we actually failed the workflow itself here. Sorry, I'm looking always at the wrong thing. So this is how you can kind of fail on non-deterministic exception. So hopefully this helps somebody if you're doing testing and you don't want to deal with this stuff. Let me just go through the code to see if there is anything else I wanted to show here just for a sec. No, I think that was it for this particular. Oh yeah, one thing I do want to talk about that does come up a lot is we have a lot of users that, for example, during their testing, start hundreds of workflows, right? Executions, and they get stuck or they get this non-deterministic error. And basically, if you look at the UI, I mean, there is no bulk terminate here, right? So and then a lot of our users are basically saying, look, I started all this, hundreds and thousands of workflows. I don't want to dealing with TCTL batch terminate. I don't want to do it via code. What can I do? And especially some users then don't know about that you can actually batch terminate workflows via TCTL and even code. They get worried. I have to now click on billions of workflows in the web UI and terminate them one by one. But one thing to do, and I know you all know about this already, but just kind of to iterate is you can always set a workflow execution timeout. And the important thing that I'm trying to say here is the recommendation that we give all users on forum and Slack is you shouldn't use timeouts for business logic. So even though like workflow execution timeout in this case is going to restrict the execution of this workflow to 2 minutes, and not only this workflow, but if this workflow, for example, retries and things like that, this is going to limit this workflow execution of all those retries as well. Meaning at 2 minutes, the server is going to say, you're done, you have timed out and time out this workflow execution. But a lot of times, if you don't set this particular execution timeout, these rogue workflows that you might have started and now have to bulk terminate in some sort of way that kind of sucks, are going to run forever until you actually do it. But a lot of times it does make sense to set workflow execution timeout, knowing that even if you start thousands of workflows and just for a test or dev environment, and you don't want to deal with them, bulk termination, that will time out in 2 minutes in this case. So just something. So don't use timeouts. The same thing for activity timeouts and things like that. Don't use timeouts for business logic. However, they are very important for some cases. For example, like this one that you need to set. All right. So I think that's it for this one. Any questions regarding, I guess this? No? All right, let's move on. Seriously, if you have any questions, feel free to ask. Let me see what else we're going to talk about next. All right. So the next thing is actually that Dmitry taught me a couple of weeks ago, and I thought it was amazing. But again, the question came from a user, is logging, right? And this is actually a very cool thing about the Java SDK that I wanted to show you. And let's see, what are we looking at for logging? We're looking at C5. No, this is wrong. But anyways, so one thing I wanted to show about the Java SDK is this logger tags. So we use by default, you can get the workflow logger with SLF, right? Yeah, SLF for J, which is a wrapper. But one thing that the Temporal SDK does, it has this logger tags. And while your workflow is executing, for example, executing a workflow, and you're logging within that inside of the workflow, the Temporal SDK writes this particular tags and their values into MDC, right? So you have these available. And a lot of people, I don't think that they know that. So the issue is a lot of people are asking is I'm logging from my workflow, but how the heck do I actually know? They're just logging hello world from inside of a workflow execution. But these same users want to know the workflow ID, the namespace of this workflow, the task queue that this workflow is executing, and things like that. And this just I wanted to show you that it's actually possible to do that with Java SDK. So let's take a look at that, I guess, if you guys have time. I guess one. Oh, I guess you have no choice. So anyways, one thing that I wanted to show first is we have some workflows and activities here, just like usual. We have a logger workflow implementation that calls a child workflow calls an activity, and we actually log in everything. So in the workflow, we log using our workflow.logger. So this is a replay safe logger. So I do some code reviews for a number of people. They use system outs here. don't use system outs because they're not replay safe. And we used that in the previous sample when we broke workflow determinism, just to show that using system outs is not safe, because you're going to see them on every single history replay during execution. So use this workflow logger, and we log in the workflow and in child workflow and activity. So let's go ahead and actually look at these logs a little bit. All right, so if we look at one of these logs, for example, invoking activity workflow, this guy right here, or yeah, invoking child workflow, which is a log that comes from our worker, in our workflow execution, what information do we have? We know that it's invoked from some workflow method, logger workflow, and we get some information here, but we don't really have much. But one thing that you can do is in our Logback XML, we can actually define different patterns. So this is the pattern that we're currently using. But one thing is that you can do is you can define your pattern that actually uses this logger tags that we showed here, right? So here we define a different pattern. So we have the namespace, and we use the namespace logger tag. We use task queue, and just TQ column, so just to so I can see it better because I'm like blind and stuff. And we can actually use all of these logger tags when to actually enhance our log. So if we do this and now run the starter. All right, so let's take a look at the same invoking child workflow, for example. Now let's take a look at our logs now. We know that our namespace is default. We're running on task queue C5S5 task queue. We have the workflow ID. We have the workflow run ID. We're not executing an activity, so there is not going to be any activity right now. Same thing, for example, for activities, I think there should be some activity. I don't know, but yeah, so basically you can enhance your logging with just using this feature of the Java SDK. And I think that's awesome. And I think that's something that maybe we've added this, actually, Dmitry has added, if you go to samples, Dmitry actually added this recently in source, main, resources, and your Logback XML. And this is the pattern that we have there. They also show how you can put in your pattern the workflow ID and the activity ID. But as you can see here, you can kind of pick and choose, from the logger tags, whatever you actually want to add that makes more sense to you. Yeah, so that's it for this. I hope it was useful. Any questions about this stuff? All right, let's keep going. Maybe we can give you some time back. What else did I want to? There was something else. Let's see. All right. One more thing I wanted to show, and for this workshop is we have, as you know, like right now we have like whenever you pass from your client some models, some classes to, as a workflow input, if you pass, let's say, an object to your activity invocation, child workflows and things like that, whenever you get a result from either workflow or activity execution completion or a child workflow execution completion, Temporal takes this payload and serializes it. And in Java SDK, we use by default Jackson JSON payload converter for this. Meaning that in order for you to be able to send, for example, a particular, like let's say a customer object to your, as input to your workflow, it has to be serializable via, let's say, either the default serial mechanism using JSON, or you can also, of course, write your own, right? But there is some restrictions, and you probably guys already ran into this. Let's say you create a customer object, and in this case, I think this is what we're looking at right now. We have a my model object. And in order for this object by default to be serializable, that is Jackson JSON payload converter, it has to have a public no args constructor. So in this case, this really wouldn't work. And we can actually show you this. We have a workflow here that takes in my model as input and does absolutely nothing except log it. So that's very hard, you know. Yeah. So anyways, so in our starter, we create a workflow stub and we pass this model to our execution. And if we do this, we will actually see that we got an invalid definition exception, cannot construct instance of my model. And if we look at our workflow execution, our workflow task failed, and we can actually see the same exception that we saw. And we know even that it's a data converter exception in this case, right? So you know, whether you use V1 or V2, and actually let's take a look at this on V2. Oh, so they don't say I just use V1. All right, so let's look at this and see we have our workflow task failed, and V2 actually, by the way, rocks. It's so much better looking than V1. Anyways, so we can actually get the whole failure message here as well. So it's the same thing, and maybe, you know, and we see the result, the workflow is still in progress and all that stuff, which is really cool in V2. And yeah. So anyways, our workflow did not fail. It is waiting for the fix of the data converter and things like that. But in this case, I'm just going to terminate it. And yeah, so whatever. So some of our users are asking is, fine, if I write my own classes, if I write my own business model, I can make sure that my class actually has a public no args constructor. However, some people are asking, look, dude, I have to use this third-party model. I'm trying to pass, let's say, some customer objects from some library that I'm using. It doesn't have a default constructor. What can I do? And yeah, so one way that I kind of solved this, especially for, you know, I was able to solve this with my model, is by doing two things, right? Number one is not to override the default JSON-JSON payload converter. So JSON-JSON payload converter has an object map, right? And it has basically a default object mapper. I don't know, here is the mapper for it. It configures Java time module, Java 8 module, blah blah blah. But you can always add to this. There is a bunch of different properties that the object mapper can take depending on your situation, and you can actually override this. Well, I don't know where I am anymore. Sorry. Yeah. So in this case, what we're going to do is we create our own object mapper, and then we use this Jackson library called parameter names module, and we basically using this library tell, hey, we only want to use properties for actually serialization, deserialization. Don't use a constructor. And we can actually register this module. You can register your own modules here or your custom conversion or whatever you want to do here. And we basically return a new JSON-JSON payload converter, which is the default using this particular object map. Now, one thing to note, in order to get this actually to work, you have to compile your code. Where's my POM XML? Yeah, so I have here in my POM my Maven compiler plugin, and in my compiler args, I do set the parameters compiler option here, right? So that's a little bit, yeah, that's needed for this particular solution to work. But once I enable this, and how do I actually do this is, yeah, so I get my workflow client options here. Now let's go ahead and get the imports in. I get a data converter, I get the default, and I override it using my own JSON-JSON payload converter, which we define here. And then what we want to do is when we create our client, we want to pass our client options to this client, which will then apply our payload converter override. And now if I run, I make sure that this one is terminated. All right. So now if I run the starter, All right, so we actually were able to print from our workflow model and the class, which is what our workflow does exactly here. And if we look at our UI, we see that we were able to handle my model object, which does not have public Norix constructor, and be able to serialize and deserialize.